So I would like to say good afternoon to all the attendees of this session. And this session is going to be an intensive session on recent advancements in aerospace and automobile engineering. And we have with us two eminent speakers, Dr. Amit Kumar Thakur and Dr. Sudhanshu. And briefly, I'll be introducing them, and then we'll go ahead with the proceedings. So we have with us Dr. Amit Kumar Thakur. He is professor and head of the department Aerospace Engineering in School of Mechanical Engineering at lovely Professional University, Fagwara. He has more than 19 years of experience in academics and research. His area of research is renewable energy technologies, biofuels, thermal engineering, aerodynamics, robotics, and IoT. And I hope you'll be getting much knowledge through his presentation regarding the same. I welcome you, sir.
Thank you, sir. Thank you.
So we also have with us Dr. Sudhanshu Dogra, who has teaching experience with us, and he is in the School of Mechanical Engineering. And he is he holds the expertise in thermodynamics, fluid mechanics, heat transfer, applied thermal engineering, IC engines, and automobile engineering, turbo machinery, and gas dynamics. And he'll be a great resource person over here. I welcome you, sir, as well.
Thanks a lot, sir.
So now I'll be handing over the things to both of our speakers for another good amount of time. Over to you, Dr.
Thank you so much, sir. Thank you so much for your warm welcome. And very good afternoon, lovely audience, and everyone who's present over here to take in the insight of the recent advancement in aerospace and automobile engineering. So I myself already have been introduced. I myself, Dr. Amit Thakur, I'm the heading aerospace department, and today we are going to share up a bit of advancements, what I say, the recent advancements in aerospace. And Dr. Sudhanshu would be taking the next session for the recent advancements in automobile engineering. All right. So coming to this aerospace industry, that what has been called upon, everybody knows about it, that the aerospace industry has been at the forefront of human technological progress for decades, right? And they are providing solutions for some of the world's most complex challenges. Aerospace basically is a branch of engineering that deals with the design, development, and the maintenance of aircrafts. Either you call it spacecrafts and the related technologies. And since the inception, like the Wright brothers, when they came up with the first powered flight in 1903, the aerospace industries has continuously evolved, and they have pushed boundaries of what's impossible, right? So today, aerospace technology plays a very crucial role in the modern society, from enabling global trade and travel to advancing scientific research and exploration. And in recent years, advancement in technology have made aerospace more efficient. It's become more safe and accessible than ever before. Innovations like urban air mobility, space tourism, they are becoming a quite rapid process and becoming in reality, right? And the industry potential for the growth and the progress is seemingly limitless. So, ladies and gentlemen, today in this webinar, we will explore more of some of the latest advancements and innovations in the aerospace industries. We'll also examine the challenges and opportunities that lie ahead, all right, including environmental and safety concern, some sort of competition in the market trends, and the government policies and regulations, right? And then finally, we'll try to conclude it up by discussing the importance of the continued investment in the aerospace technology and innovations to ensure a bright future of the industry as a society and as a whole. So coming to the advancements in the aerospace technology, advancements in aerospace technology have played a critical role in improving safety, efficiency, and sustainability in the industry. when we talk about, you could see over here into the graph over here, the point 1, 2, 3, 4, 5, 6, 7, 8. These are the basic the advancements which we are moving towards. And the very first one that what we consider is a zero fuel. Zero fuel aircraft is one of that, say, brainchild of Airbus. And I think so that would be in the service by 2035, which is considered to be the most of the latest advancement in the aerospace industry that is undergoing some sort of development. The aircraft will be using hydrogen basically as a primary source, and it will not release any carbon emissions. So this plane will be significant, having a significant advancement that may decarbonize the aerospace industry, providing a cleaner way of travel. So what we are today dealing with, so is what we consider renewable, right? Renewable energies and all those kind of stuff. So hydrogen would be one of the promising fuel in the aerospace industry, if at all this comes down into picture. So a lot of work, a lot of advancement is going along onto the zero fuel technology. Then you talk about certain lightweight materials. Material is one of the most important, say, stronghold, which has a very strong hold onto this aerospace industry. That the use of this lightweight materials, like we're talking about composites, we talked about alloys, they have significantly improved their plane performance. They have taken toll onto fuel efficiency and safety. So advanced composites are basically used to build modern aircraft structures, which are considered to be lighter, very stronger, and more durable than the traditional material like we are talking about aluminum. So these materials are also more resistant to fatigue and corrosion, thereby reducing maintenance costs and the downtime. So this material, advanced materials, is also going to be one of the most important, or rather say, there are a lot of developments coming up through this part. Then comes down when we talk about additive manufacturing, or say the 3D printing, which we consider. Additive manufacturing or 3D printing has basically revolutionized the production of aerospace components. The technology that allows these engineers to create complex geometrics with high precision and accuracy, reducing wastes and costs. And 3D printing also allows for the rapid prototyping, which we are talking about, and the customizations, making it more ideal for creating parts that require high level of accuracy and complexity. Then the most important one, which everybody now, it's a trend for everyone, like artificial intelligence and machine learning, right? So artificial intelligence, AI and machine learning are being used to develop smart systems and automation in the aerospace. So these technologies, they help improve safety and efficiency by enabling real-time monitoring of aircraft systems, basically into the predicting maintenance needs and enhancing the flight control systems, right? So artificial intelligence, basically it encompasses the machine learning. So machine learning with AI can solve complex problems, and calculations becomes much faster than the human brain. So they can also recognize the patterns and determine the outcomes of the simulations. So AI can report on the climate conditions, what we are considered, right, which is very important in aerospace sector, right? And then evaluate the framework status. They can determine what is the fuel levels and many more, right? So to create new technologies for the aerospace industry, engineers and scientists, they are working, or they are using, they also use this AI run simulations. They create new materials, and then further they solve different problems. To the next slide, sir. So looking onto this, the one important thing which comes along is one more, is called electric propulsion, right? And when I talk about electric propulsion systems, they are considered to be as emerging as the most promising, or say most promising alternative to traditional jet engines. Electric aircraft engines are considered to be very quieter. They produce fewer emissions, and they have the potential to reduce that operational costs. And advances in the battery technology are making these electric aircrafts more practical for the short range flights and smaller aircraft. So that technology basically uses electric power to generate, or say to accelerate the charged particles and generate that heavy thrust. That's what we consider, right? And under the categories, there are a number of categories which we consider: resistor jets, arc jets, then electrostatics, we have GI, HET, FEP, then electromagnetic, we are talking about pulse plasma thrusters, PPTs, and magnetoplasma dynamic thrusters. So these are considered to be one area where things are moving really fast. So electric energy, depending upon the process, basically how to accelerate the propellant, these electric propulsion thrusters, they are categorized. Yeah, please go. So, and you talk about the EP, that is what you could see it over here. Like it will be from applied to everywhere, from micro to mini satellites. We talk about propulsion power and reliability. Then if I talk about high power EP systems, space missions even, right? And few are the challenges. See, everything which comes with a positive aspect do have a negative aspects also, right? So there are few challenges which has to be taken care. It's fast innovation and strong competitiveness, drastic reduction of the manufacturing cost, which could be, and then the standardization of the EP testings, quality, fidelity, numerical models. There are a lot of stuff which has to be taken care onto it. So somewhere rather, this could be the future of aerospace, what we consider. And a lot of work is really going on onto that. Scientists across the world, DRDOs and all the labs, and all those government labs where the scientists, eminent scientists are working behind onto it. They are doing onto their best to see through that this comes to a future. Excellent. And then one will talk about this considered to be reusable rockets. When I'm talking about reusable rockets, these are the spacecrafts that can be recovered and reused after the launch. This is one important thing which we normally falter into it before, that we were never using those rockets which once goes into the space, right? So the concept of this reusable rockets has revolutionized the aerospace industries in a lot of ways. The one basic aspect is the cost reduction, which we are talking about, right? So significantly, if I'm utilizing that reusable rockets, so the cost of our space missions, they are eliminated to a greater extent, right? So it's not required to, again, to go down and manufacture new rockets after every launch. And then the accessibility increases. So you could find more space, more accessible for lowering the financial barriers for the space exploration and the satellite deployment. Technical advancements are many more when we talk about more towards the materials propulsion side onto it. So, additive manufacturing, I've already discussed with you how exactly it is, right? So you have to create 3D objects by adding material layers. So manufacturing in terms, we can go down and prepare complex geometry predictions. We can create intricate and complex geometries. Why we talk about additive manufacturing, because there's part of weight reduction also. So creating any complex lattice structures and hollow parts by reducing the weight, which maintains the structural integrity. And that's the more that what we consider about, shifting towards more lighter alloys, lighter metals, so that the cost also goes down and then the prototyping can be done efficiently. So cost reduction is a direct production of the parts without the need of extensive tooling or assembly. Right. So components which can be produced basically through this additive manufacturing, any engine component that what we talked about, right? Fuel blades and combustion chambers. We have structural components that what we consider, right? So there are various structural components that what we talk about, brackets, supports, panels, then spacecraft parts, antennas, mounts, sensors, housing and brackets, everything could be manufactured through this additive manufacturing, right? So go ahead. This one important area where we discuss about. So, yeah, and then what we consider about is a hypersonic flight, that what we talked about, right? So everybody is now aware of all this. Everybody wants to know more about this all. So hypersonic and supersonic are the opening up. They are basically opening up new possibilities for a high-speed travel and the space exploration, right? So hypersonic vehicles, they can travel at a speed exceeding 5 times the speed of sound. So making them ideal for the military and the scientific applications more closely, right? So supersonic commercial aircrafts could significantly reduce travel time for long haul flights and open up new markets for the air travel. So this is one area where things are things are going on very fast onto it. So significance are a huge, and the applications can also come to a greater extent. Next slide. Then we talked about the autonomous system, that what we consider. And before that, one thing I would just like to talk about is Structural health monitoring is also one system that reports the health of the aircraft. And way back in 2007, NASA created it up. And that technology basically evaluates the power systems, fuel systems, communication systems. You talk about landing gears, you talk about almost every system of that airplane. So that is also one area where advancements are really going along. That is what we call SHM, structural health monitoring of the aircraft, right? Then coming back to this autonomous systems, which is enabling the development of self-operating and self-controlling systems, which we talked about. And they are equipped with all kind of sensors. We say AI and decision-making algorithms. We have sensor technologies into it. You embed artificial intelligence and machine learning to that. Right. So innovations in aerospace industry, they are shaping the future of the air travel and the space exploration, that what we talk about. And I talked about this urban air mobility, right? So urban air mobility is one new area of focus in aerospace that basically aims to provide new forms of transportation for urban areas. So UAM involves the small use of eVTOL, that is what is called electric vertical takeoff and landing aircraft, basically to transport the passengers from the cargoes in the urban areas. So that is one innovation that what I really believe will be the future of aerospace. And then what we consider, yes, sir, go to the next slide, please. What we talk about is space tourism. So this is one where it is considered to be emerging as a new market for the aerospace industry. So you have heard about SpaceX, right? So private companies like SpaceX, you talk about Blue Origin, you talk about Virgin Galactic, they are developing space tourism programs that will allow civilians, basically like for us, some of us, to travel to the space for the very first time, right? So these programs will offer suborbital flights, allowing passengers to experience weightlessness and see the Earth from a new perspective. So there are all types of design and development of the spacecrafts for the space tourism are going into account. So some or other way, we are getting more closer towards this aerospace sector, right? So it's becoming more and more fascinating towards this areas. So that is what it is basically being required to it. And then when we talk about one more very important thing, which is considered to be HALE vehicles, which are considered to be high altitude, long endurance vehicles, HALE, right? And these are considered to be unmanned aircrafts that which can operate at a high altitudes for extended period of time. So these vehicles are basically used for scientific researches. I'm talking about surveillance, talking about communication purposes. So HALE vehicles, they have the potential to transform how we gather information about our planet. And then how can we go down and provide new solutions for the communications or disaster purposes. Now, yeah, next. Coming to the challenges, and I'll come to the just and then I'll conclude it up slowly. And then we talk about challenges and the opportunities in the aerospace, what we consider about. See, this aerospace industry basically faces various challenges and opportunities as it continues to evolve and innovate, right? So if I'm talking about some challenges, which I'm talking, one major concern is the environmental concern. Aerospace industry is a significant contributor to the greenhouse gas emission, which is a major contributor to the climate change. So as a result, there is a growing pressure to reduce the emissions and improve sustainability in the industry. So aerospace companies are investing in new technologies, such as electric propulsion, which I talked about, and sustainable fuels, which I'm working on to it. Some few fuels I'm also working on to the sustainable fuels for the, so substitute of that what we are having fuel to basically to address this challenge. Then the safety is one important concern. If I'm talking about the safety of the passenger and the crew, that is considered to be the top priority in the aerospace industry. So the increasing complexity of that aircraft system and the growing demand of air travel, they create new challenges for safety. So in order to address that up, AI as well as machine learning based predictive maintenance and improved pilot training will provide some sort of safety features also. Then we talk about competition and market trends. The aerospace industry is becoming highly competitive nowadays. Okay, with a lot of companies flourishing in, and they have a lot of shares. So new entrants, which I'm talking about, SpaceX, Blue Origin, they are disrupting the industry with the innovative technologies and business models. So in order to remain competitive, established aerospace companies must continue to invest in innovations and adapt the changing in the market. Few government policies also has to be framed, or rather say it could have to be taken into account. And when we talk about young budding engineers who take up aerospace engineering as their core course, or they want to study aerospace engineering, the opportunities are huge. So when I'm talking about the growth and the expansion of aerospace industries, they have significant potential for the growth and expansion. Like I'm talking about new markets emerging in the areas like UAM, space tourism, unmanned aerial vehicles. As these markets, they are continuing to develop, there will be new opportunities for the companies to expand their operation, and then they reach down to the new customers. Second opportunity that what we consider is technological advancement in the aerospace technologies. They are creating new possibilities for air travel. You talk about space exploration, I'm talking about scientific research. So all aerospace companies that invest in these technologies, they can gain that competitive advantage and position themselves in a longer run. Then collaboration and partnerships between aerospace companies and the government and also other stakeholders, they can drive the progress in the industry. So these partnerships, they are leading down to new innovations, improved safety, and better sustainability practice. So, ladies and gentlemen, the future of aerospace is filled with exciting advancements and innovations. It's very less that I could go down and talk about more towards advancement in this one hour of session. So, there are a lot of things has to be explored onto it, but the future of aerospace is exciting. It's very filled with exciting advancements, innovations, which will shape the way that we travel and explore space. Ever since my childhood, it was very fascinating to learn about space and all other materials like aerospace, right? So starting from the electric propulsion to autonomous aircraft and the space tourism, the aerospace industry is poised to revolutionize air travel and space exploration. So, however, these advancements, they come up with significant challenges, such as the need to reduce emission, improve safety, and comply with the government regulation. So, aerospace companies, they must also adapt to the changing market trends and compete with the new entrants in the industry. And basically, despite of these challenges, the aerospace industry has significant opportunities for the growth and expansion. New markets are emerging, and the advancement in the technologies are creating new possibilities for air travel and the space exploration. So collaboration and partnerships with the industry stakeholders, they can help to develop up this and progress further in order to overcome these challenges. So coming to this, that is what I had with me with the recent advancement in aerospace, right? So we talked about more towards innovation. The future of aerospace engineering, they basically rely on the pursuit, they rely on the passion to explore it, what lies beyond. Thank you so much, ladies and gentlemen. So I'll now hand over my session to Dr. Sudhanshu Dogra, who will be taking up with automobile.
Thanks a lot, Mr.
Thank you.
Let me start with it now. Okay. So good afternoon, everybody. This is Dr. Sudhanshu, heading Automobile Engineering Department in School of Mechanical Engineering at LPU. So I will be giving my webinar on recent advancements in automobile sector, automobile engineering. So, you know, everybody of us are surrounded by automobiles. There is a great saying actually, which says that it's a quote we can say, which says that take care of your automobile and the automobile will take care of you in the road. The thing is, there are not many things in our automobiles. We have cars, we have scooters, we have bikes in our home, but we don't know actually what are happening inside those. And there are so many advanced features which we generally don't know. So this webinar will tell you about some of the advanced features, but before moving forward, let me tell you about the history from where the automobile evolution started. So to start with, automobile engineering, it's a branch which deals with the manufacturing, designing, and all the mechanisms in automobiles. Okay. So if I'm starting, if I go by the history, it all started way back in 1887 by Carl Benz. You know, Mercedes-Benz, there are a lot many cars of Mercedes, which you can see in the road. So he's the same person actually who started the automobiles. So he developed a gasoline powered automobile. Gasoline means a petrol powered automobile, and he made several copies of it, but it was not in the mass production unit. Okay, so it started with this, and in 1908 Ford Motors was the first company who mass produced the automobiles. So you can see the type of automobiles. You might have seen these in some movies actually, the historical movies. So these are the automobiles. These were the first automobiles which run generally in the roads earlier. Then, going by the eras, in 17th and 18th centuries, it was China who way back in 1672 started an automobile which is steam powered. It was very easy to run an automobile with the help of steam actually, because we already there were some steam engines which were running at that time. So it was a steam powered engine, but it could not carry a driver. It was just we can say that a prototype. It was a model actually which they created in 17th and 18th century by the Chinese peoples. Then in 19th centuries there were some engines which are working which started steam, which took steam for the movement, okay, from one place to another with the help of a driver. Okay, so these were the wagon wheels which started in 19th century. So you can see how much time did it took from a steam powered engine which was without a driver and which was with driver. It took almost a century. Okay, then in 20th century, before World War II, there were so many evolutions going on in this sector. Okay, because for the war purpose, there are so many equipments and there are so many things which needs to be transported from one point to another. So at that time, at that era, actually, internal combustion engines were started. Okay, they came into picture, which we are running now also. Okay, so it was in the 20th century when IC engines started. Then if I'm going by the advanced technologies, by the advancements, you can say there are so many things. There are we can say that airbags, but these are the technologies which are obsolete nowadays. Okay, so the first advanced technology was in the form of electric vehicle, we can say it like that. It was started in 1890. Generally EVs, if we can read the news nowadays, you can find so many articles on EVs, but many of us don't know that it was started way back in 1890s. Okay, so this was the first electric vehicle. You can see it in the picture. How does it look like? But the thing is that the battery range is very less, the speed was very less, and it was a very high it was in a very high cost side. That's why the electric vehicle technology has not been used much at that time. Then coming towards the first turn signals, you can say, you can see that whenever we want to turn in a road, we have to signal it. So it started way back in 1909, and it was mass produced, or we can say that it came into picture nicely in 1930s. So you can see that the advancements took more than 30 years to get the first turn signals. Okay, so this was the turn signals. Generally you say these as indicators. Okay, then some advanced features. So let us go by some advanced features which you might not know, because these are the advanced features which are not there in normal automobiles. One of the most important one is blind spot information system. Now what does it mean? Whenever I'm talking about the blind spot information system, you can see that there are three mirrors, okay, where you can see at the back what is coming from your back. Okay, but there are some blind spots which you cannot see in the side view mirrors. Okay, so this feature are in some high-end cars like in Volvo XC60, which has been written over here. Suppose some cars or some vehicle is approaching at you at a very high speed, there is a light built in the side view mirror which illuminates, which starts blinking as soon as it is behind your car. So it will warn you of its presence. So this is the blind spot information system, which is in some high-end cars. I'm not talking about the cars which you generally found in the roads nowadays, but these are in Volvo, these are in Mercedes. So this is the advanced feature which generally are there in these cars. Then the second one is the reverse assistant. Now, what does this reverse assistant means? Okay. Now the thing is, suppose you are in some hilly area and you have drove, let's say 500 meters, or let's say 100 meters. Okay, there are so many turns in that. But suppose you want to get back and there is no way that you can turn your vehicle. Okay, so reverse assistant is just a button which you can press, and it will take the same path in which you have forwarded earlier, in which you have proceeded earlier. So you don't need to do anything, you don't need to see anything behind. It's just a simple button. You just click that button and your car will move back on the same path in which it has come. It is generally found in all the BMW series. Okay, but over here I have written that we are curious to see how it works in India. Okay, it is very, very tough actually due to the roads we have, due to the hilly areas we have. Now the adaptive control or the cruise control. This is the third one, third advancement we can see. So the cruise control system, everybody knows actually. It is a system which takes you to a particular speed, which takes you, which makes you maintain a particular speed. Okay, it's just a simple button actually. It will accelerate by itself. So these generally are found in lower end cars also. Adaptive cruise control. Okay, so over here it is written that, okay, if the control system, it will have a same gauge speed, so that you don't have to do anything. You don't need to press accelerator again and again. Suppose the road is totally smooth, okay, it's a good highway, the road condition is good, you need to just push a button and it will make you it will drove you to a similar type of speed which you want actually. That is your adaptive cruise control. Now moving forward, the active roll mitigation system. Now, what does it mean? The thing is that apart from head-on collisions, which has been written over here, okay, suppose you are going at a very faster speed. There are so many sharp corners in your road, okay. So to prevent the collisions with some another car which is coming from the other end, active roll mitigation system is being used, which directly applies brake by itself. Okay, so you need not to do anything. It will come into act as soon as some sharp turns will come, and it will make your car drive safer. It is generally being used in Lamborghini URUs. Okay, then emergency response. This is one other advancement which you can find in BMWs actually. Okay, now emergency response, what does it mean? Suppose any vehicle, I'm talking about, let's say BMW, gets stuck or get hit by another car, then what will happen? This response will start which will switch on the parking lights by itself, and will send the crash details to the nearby police station and nearby BMW center. In this case, actually, okay. So you need not to do anything. Means it might be the case that the driver is unconscious, so he cannot do anything. So in that case, what will happen? It will switch on the parking lights, it will give its signals to the nearby police station and the fire station, and everything goes by itself. So this is your emergency response. Now one of the most important one, the driver fatigue alert. Now what does it mean? Actually this particular alert senses the we can say that uh, the driver, which senses the driver actually. Okay, now what does it mean? Suppose the driver, suppose you are driving in a road and you already drove, let's say 500 kilometers, okay, and fatigue is coming into you. So what will happen? It will make a audible sound, so that you can means you there are so many cases actually. There is a case earlier in the year also, in the last year or year also, when Rishabh Pant is driving a vehicle and he slept actually, and in between the in between the road, and the thing is that his car crashed. So in that case, what will happen? It will start a audible sound, okay, which will tell you that you need to be alert actually. And also navigation system will starts on its own, and it will tell you to stop at some coffee shop and at some launch, etc. Okay, it is generally been found in Jaguar. So these are some of the advanced features actually, and there are a lot many others also. There are hundreds of advanced features which you can find in high-end cars, and even in lower-end cars also you can find so many of these things like adaptive cruise control and all. Okay, now coming towards the autonomous cars, the advanced vehicles, let me tell you about the autonomous car first. Autonomous means working by itself. You might have heard about Tesla. There are so many articles you can find of the autonomous vehicles nowadays. Okay, so what does it mean? It is a type of car which is capable of sensing its environment and operating without human involvement. Means you don't need to do anything. Okay, it will move on its own. Okay, it will not be taking any intervention from the driver actually. It can go anywhere where a traditional car goes, but there are so many challenges in it. There are so many actually. If I'm talking about the challenges, let's start with it. Weather conditions. Suppose the road is totally icy, let's say. Okay, then what will happen to the autonomous cars? Okay, it needs to control the speed accordingly, but this is one of the major challenge, the weather condition. This, what happens when an autonomous car drives in a heavy precipitation, okay, or a snow layer is over there, or suppose there are some oil which gets spilled on road. So what will happen in that case? This is one of the major challenge. The second challenge is accident liability, very much important. Now, who is liable for accidents? Let's suppose there is an accident of autonomous car somewhere else. So who will be liable? The manufacturer, the human passenger? And why human passenger? He's not doing anything. Okay, actually, he's just sitting over there. Okay, so the thing is that the accident liability is one of the major factor why it is not being used publicly. Okay, now again, let's move on towards this uh, artificial versus emotional intelligence. Now over here in India, we can see that human drivers rely more on non-verbal communications. Okay, generally they make the eye contacts that yeah, you can go at that point, you can stop and something like that. It cannot be done by the cars, the autonomous cars actually. So artificial versus emotional intelligence is one of the major factor as far as our country is concerned. Okay, it is being written over there that will they have the same life-saving instinct as human drivers? Will autonomous cars be able to replicate the connection? So it is one of the major challenge actually. Now benefits, so many actually. Reduce the traffic congestions in one is one, 30% fewer vehicle on the road. Cut transportation cost by 40% is other. Improve walkability, free up parking lots, reduce urban CO2 emissions by 80% worldwide. But it will only be possible when everything is autonomous. Actually, 80% is the data. It would be achieved when everything is in automated way. So now these are 6 levels of autonomous vehicles. Actually, the first one is no automation. Now, no automation means that full manual control, the vehicles which we are driving actually. Okay. Second one is driver assistance. Now, driver assistance means the vehicle can assist a driver with a single automated system. There is only a one automated system. Okay. It can be a cruise control. Okay. Rest everything is in the hand of driver. We are generally using it nowadays. The second one is your partial automation. Okay. The vehicle can perform both steering and power control, has been written over there. ADAS. ADAS means automotive driver assistance system. Okay. Partial automotive means 50-50% actually. Okay. Now 50% is in the hand of driver, 50% is in the automated way. The conditional automation. Okay. The vehicle can perform the majority of function. You can say 70-30. 70% is in the hand of, we can say that in the automated way, and 30% is in the hand of driver. High automation is the next one, in which the vehicle can perform all the driving tasks in certain circumstances. Now this is the major one actually. This is the good one. Okay. Now the thing is that what is full automation? Full automation means a driver is no longer necessary, as a vehicle can perform all the driving tasks without override. And in this full automation, there is one drawback actually. You cannot control what a vehicle is doing. Okay. In high automation, you can control it. Let's suppose in fully automated, let's suppose it is in the automated control. A car is in the automated control, but still, due to some road conditions, it failed to take the necessary action. You can take the action in high automation type, but you cannot do anything in the full automation type. Okay. So these are 6 levels of autonomous vehicles. Now, coming towards the next technology, and the next technology is EV. A small concept actually. I told you it started way back in 18th century actually. Okay, it started with a small model created by a Hungarian priest in 1828. Then 1832 to 1839, Robert Anderson invented a crude electric carriage actually, which can take the baggage from one end to another. Okay, then 1835, it was in Netherlands, okay, which created electric car powered with non-chargeable battery. Means you cannot charge the battery. As soon as the battery gets ended up, your vehicle stops. You cannot charge it again. Then in 1891, they created the first electric automobile in US. And then in 2008, Tesla is released, you know it. Now, how does it work? Actually, everything is same, but it is being replaced. It replaced IC engines. Okay. Now, why we are replacing IC engines by electric vehicles? The thing is that quite simple. The fossil fuels scarcity. The fossil fuels are exhausting at a very faster rate. We need to look at some other resources which are in plenty actually, and the harnessing has not been done yet to full extent. So that's why we are moving toward the EVs now. Now, how does it work? It is replacing IC engine, I told you, with an electric motor. Okay, you can easily plug plug in a charger, and you can charge your battery, and you can move from one place to another. They are having some rechargeable batteries into it, which can be charged in some charging stations. And let me tell you guys, in Canada actually, there are so many charging stations. One of the major problem which we are facing in India is that the charging stations are very less. So in Canada, there are so many charging stations, and even they have given some subsidies to some homes also, which can work as a charging station. So inside home only, they are having a charging station which can charge vehicles coming at their way, and you can move from one place to another without thinking about the discharging of battery. Okay. Now, the advantage is easy to recharge. Okay. It is very easy to recharge actually. Even a normal household socket could be used for charging, which I told you earlier. In Canada, it is going like that. Okay. There are so many charging stations in home itself. Okay. There is no need to buy any gas again. There is no emissions. One of the most important things, there is no emission of any harmful gases. So we can say that the pollution gets reduced. Okay. Then it works on electricity, so the maintenance is less, because if I'm talking about IC engines, there are so many filters which needs to be changed again and again whenever we are giving our vehicles to servicing. You can see the costing. It generally comes out to be 10,000 for a single service, because we need to change the filters, we need to lubricate the systems and all those things. So the servicing cost would be less. Okay. Now the challenges are charging points are less. I told you earlier. Charging time is much longer. Even in fast charging, it takes 30 minutes to charge 80% capacity. So not very, means we can say that it is not a very high time, but still we are taking it as in the challenge. EVs are much expensive. You can see that EV vehicles are very expensive nowadays. We cannot afford it because it is not being produced in a mass scale as of now. Okay, the top speed of EVs are very less as far as the conventional vehicles. Conventional means the vehicles which we are generally running, like IC engine vehicles. Okay, and electricity demand will increase, which will increase more power plants to be installed. So these are some of the challenges. Now coming on towards the cyber security. Cyber security means there are so much of data in your cars. If you are talking about autonomous vehicles, there are so many data. Okay, so it can be hacked by some hackers. So automotive cyber security is one of the most important thing which are in which the researches are going nowadays. Okay, now if you can see that the layered cyber security concept. Okay, so let's take an example of autonomous vehicles. Okay, autonomous vehicles doing everything by its own. Okay, so we need to have everything secured. Okay, so there are some gateways, there are some layered concept which they have produced, which engineers have produced. Firstly, the external communication, because let me tell you, autonomous vehicle moves on its own. Okay, so it might be the case that the hacker can take your vehicle from one place to another with the help of some program. So the thing is that cybersecurity is the concept which dealt with all these things. So there are these four gateways: the secure platform. Firstly, the secure external communication. You can see that there are a lot many things in the external part. So this needs to be secured. The secure gateway from where you are entering the vehicle, it needs to be secured. Secured internal communication, one of the most important factor, because there are so many sensors. And let me tell you guys, there is one other factor or we can say that the challenge in case of an autonomous vehicle. Uh, Autonomous vehicle actually has so much of data inside it. Okay, and there are so many we can say that we need to have a high capacity hard disks which can store all the data, or which can send it to some satellites, and based upon that it will work. So one of the other challenges is that how we will have that much data stored actually in some hard disk and so on. Okay, so that is one of the other factor. So cyber security is the concept which makes your car theft free actually, and which takes your data, which we can say that which will not leak out your data to the external sources. That is what the cyber security means. Okay, so how to implement cyber security? There are so many things we can prevent it. First thing, if it is not being prevented, we can predict. Okay, means how the hackers can going to work, then we can detect, and after detection we can respond. The thing is that cybersecurity is one of the most important thing which needs to be looked upon as far as the autonomous vehicle is concerned. So the thing is that in conclusion, I can say that there are so many things which you can do as an automobile engineer. Okay, there are so many different concepts which are going on nowadays. Like in case of your cybersecurity, in case of your AIs, in case of your ML machine learnings, there are so many things which you can do. But the thing is that the harnessing, or we can say that the technology advancements are going at such a high rate that there is very less space to think about it. The thing is that you can do so many things as an automobile engineer in terms of the cyber security, in terms of your machine learning, in terms of your artificial intelligence, in terms of your EVs. Even you can have a vehicle created which can work at a very high speed as that of our conventional vehicles. So there are a very high scope as an automobile engineer, because this particular field is being evolved at a very faster rate. Okay, there are so many things, and in the coming, let me tell you guys one more thing, that the concept flying cars are also in the radar now. You can see so many videos in YouTube in which the cars actually are flying. So there are a lot many things going on. We need to see which factor, which sector we need to pick actually. So this is all about the automobile engineering advancements, and there are a lot many other things also. Okay, so thanks a lot. If you have any queries, you can ask me. Thanks a lot, guys.
Thank you so much, sir. It was really a wonderful session, and you threw light on advanced vehicles, emotional intelligence, and electric vehicles as well. So I would request all the attendees. I can see Amrita has joined the webinar. Bala Revath is there. John Albert, Hariman Kaur. So in case Riddhi Malhotra is there, so in case you have any query, the experts are with us. Definitely will be happy to take up those queries, and you can come up, you can raise your hand. I'll be connecting you to the resource persons over here. You can write your query onto the chat box even, and we can take up those queries. So you need to be a little more quick onto that. Shruti Vani, in case you want to ask something, you can. So I'm waiting for all the attendees to raise the query. Sir, you can stop sharing the screen right now.
Sure, sir. Done.
So there is one query from Sudhanshu over here. Not Sudhanshu, I suppose. He is Karan Verma. Karan Verma wants to know what is the scope of aeronautical engineering in this, and how will my parents be convinced to if I want to convince them to help me joining this aeronautics, how will I do that? So they are more worried about the placements.
All right. So I'll take up that. Sudhanshu, what's his name?
Karan.
All right. Karan, first of all, convincing is an art which you need to master over years, right? And by now you must have done that. So convincing your parents through a valid point is very necessary, because if you are really interested, first of all, I will take up that particular word, whether you're really interested in aerospace, because that interest is what is basically required if you take up any engineering program, right? So if at all you are very much sure about, or rather say, if you have keen interest towards aerospace, then you can always join our program over here at Lovely Professional University. And moreover, coming to the job aspects as well as the placements, which I have already told, like you have seen this, and to believe me, coming down 2 more years down the lane, 2025 or 26, the aerospace industry is becoming the largest, or rather say it is booming up every day, right? And the recent advancements which I discussed today, these are the basic trends which are coming up every now and then. And there are a lot of openings. Government is also working onto it. And towards this, if I talk about that aviation sector, they are more towards this military as well as the defense areas, right? So a lot of amount has been sanctioned towards this, and they require engineers up to date. So coming to 2 more years, 3 more years, the sector is like booming up like every day. You see today's UAVs, all these autonomous vehicles, they are coming into existence. There are government projects which are coming through. And even if students who are the 12th standard also, or 10th standard, they are working into some sort of, they are taking up certain courses on diplomas or certain short-term courses on UAV manufacturing and all those. But believe me, if you are a BTech aerospace engineer, you'll be having a better insight towards that, what exactly we are going to do in the industry, right? So convincing your parent as well as taking up this course are two different things. The interest is what is being required. And if you are really interested towards aerospace engineering, you can always opt for that. And the job prospects are huge. A lot of research areas. You could do your MTech programs, you could do your PhD programs, you can study abroad, right? So a lot of, and so you see government sectors, DRDOs, all HAL, NAL, AD, YADAs, everywhere, they all are coming up. ISRO is coming up with a lot of projects, a lot of job prospects are coming up every day. Every day I could see it onto that website. Like every now and then there are jobs opening for scientists. There are government jobs. Even if you can qualify GATE exams, you can pick up GATE exams and go for EMTech programs, right? And after that, the placements are not limited onto it. A lot of companies, and there are a lot of startups which have come up. Either you talk about in Bangalore, Hyderabad, Chennai, you see all are coming, every particular, even if a software company, if I'm talking about, they are also opening up an aerospace in the sector to them. They are attaching, and because there are a lot of projects which are coming in, those projects has to be handled. And for that, they require qualified, skilled engineers. Just to have a BTech degree is not sufficient enough, but to gain up more towards skill enhancement is one of the most important features, right? So that's what you could go down and talk to your parents and just convince them up that the future is considered to be bright. That is what.
Wonderful, wonderful. So Peter Albert has one more query. Can we take up one more?
Yeah, sure, please.
So we have a query over here. So according to him, artificial intelligence and machine learning is definitely integrated into aerospace and automobile systems.
Yeah.
And they have their own benefits.
Yeah.
Now, as a student, are we going to give him the required knowledge of artificial intelligence and machine learning as well before or during the program that we are offering?
See, what I would suggest is like what I just want to talk, because nowadays artificial intelligence and machine learning are basically used to develop smart systems and automation in the aerospace. So once you come down to a BTech program, you'll be having this, because we have embedded a few courses of artificial intelligence and machine learning also, which you will be giving insights in the very first semester or in the second semester, right? So the basic understanding of artificial intelligence will be provided. The insights will be provided through our course curriculum, which a student will be able to develop, or rather say will be having software programs based upon that. You could take up practical labs, you could do certain sort of projects based on artificial intelligence, which will prerequisite is something which you just need to know the basics of it. Nothing much in the depth part of it. We'll provide you the all insights of artificial intelligence and the application towards aerospace industry. We are not talking about the depth of that. I'm not a core computer science engineer, right? So I need to know the basic codings of it. And if at all you look onto the curriculum part of Lovely Professional University and aerospace sector, aerospace engineering, you could find all those softwares embedded into it. Either I'm talking about Python, either I'm talking about C, C++, programming. So starting from the very first semester to the 8th semester, we prepare you. Or rather say, we give you all those insights apart from the learning the basic subjects, the core subjects, English, physics, chemistry, everything will come into account, right? So you'll be having a clubbed feature of everything when you come, once you pass out in your 8th semester. So prerequisite is just having a basic, simple knowledge of what artificial intelligence is and machine learning is. Nothing more.
Wonderful, sir. That was really, really very insightful. And I hope Karan, and John, your inquiries are well settled by the...
I think so. So there is one more question from Shruti Vani. I could see it. Have already taken admission in LPU Aerospace Engineering, but I want to know in which sectors can aerospace. Shruti, it's like this question is open to everyone, or like say everybody wants to know in which sectors an aerospace engineer can work. Aerospace engineer can work in sectors where we are talking about either, I'm talking about, see, Capgemini also recruited aerospace engineers, right? Because I told you, every sector is now having a aerospace industry, aerospace department to them. Why? Because I told you there are a number of projects which are flowing in. That projects has to be handled by engineers. So even if I'm talking about designing, even I'm talking about manufacturing, if I'm talking about having simulations, learning, or rather say documentation, there are a lot of documentation companies which hire up aerospace engineers. So you could work in all sectors. It's not like limited that I cannot go down into that particular industry. But yes, something related with aerospace sector, that would be much better for to your response, because the way that you have taken up through this particular course for 4 years, so you must be knowing more about aerospace engineering. So more towards, inclined towards that. So try focusing more towards, because every company today nowadays, they are more towards the designing aspect of it, or simulation. Because the manufacturing units are very less in India, but still they are under development onto it, according to Sri Narendra Modi ji, Prime Minister of India. So maybe we'll be having a lot of manufacturing units set up in the coming 2-3 years. So in that case, you can also work over there. So there are a lot of sectors which are open onto it, where we can go down and work as an aerospace engineer. Right?
Shruti, I hope your query is well answered by Dr. Amit Kumar. And so now we are going to formally end this webinar. Definitely thanking Dr. Amit Thakur and Dr. Subhanshu Dogra for the same. And I'll be formally adding few lines. In conclusion, today's webinar on recent advances in aerospace and automobile engineering has shed light on groundbreaking innovations that are shaping these industries. From cutting-edge propulsion system to autonomous vehicles, the future holds immense possibilities. We hope this event has inspired you to push the boundaries of engineering and embrace the transformative power of the technology. Thank you for joining us, and may you embark a journey of exploration and innovation in exciting fields of aerospace and automobile engineering. Thank you so much. Signing off.
Thank you so much. Thanks.